let's explore the properties of the function f of x equals 1 plus x squared and show that it's neither one-to-one nor onto. First, let's visualize this function. Here's our coordinate system. The graph of f of x equals 1 plus x squared is a parabola that opens upward and has a vertex at the point 0, 1. This is because the smallest possible value of x squared is 0, which occurs when x equals 0, making the minimum value of the function equal to 1. Let's first show that this function is not one-to-one. A function is one-to-one if each element in the codomain is paired with at most one element in the domain. In other words, different x values must give different y values. Let's look at x equals 1 and x equals -1. When we plug these into our function, we get the same y value. Let's verify this algebraically. When x equals 1, f of 1 equals 1 plus 1 squared, which equals 2. When x equals -1, f of -1 equals 1 plus -1 squared, which also equals 2. Since we found two different x values that give us the same y value, the function is not one-to-one. Now, let's show that the function is not onto. A function is onto if every element in the codomain is paired with at least one element in the domain. In other words, every possible y value must be hit by the function for some x value. Looking at our graph, we can see that the function never outputs any value less than 1 because x squared is always non-negative. Let's prove this algebraically. Let's try to find an x value that gives us y equals 0. If we set f of x equals 0, we get 1 plus x squared equals 0. Solving for x squared, we get x squared equals -1. But this is impossible in the real number system because no real number squared equals -1. Since we found a y value, namely 0, that can never be reached by our function, we have proved that f is not onto. Therefore, we have shown that f of x equals 1 plus x squared is neither one-to-one nor onto.